We're looking at a problem here in homework 5, which involves mainly dependent events, but also has some independent events. We want to find some probabilities using addition. So we want to go through, now we've expanded our abilities to find some probabilities. Find the probability that when you go through this deck of 52 cards, that you get the 7 of spades. The 7 of spades is a 7 at the same time that it's a spade. So I'll go down to 7s and I'll see 7 of clubs, 7 of spades, 7 of hearts, and 7 of diamonds. And if you did hear one of those where I said that it was the 7 of spades. So that was actually one card out of 52. That was a 7 and a spade at the same time. Now of a black card. It doesn't fully show it here, but clubs are black and spades are black. Hearts are red and diamonds are red. So what we have, if I want to find out the probability of getting a black card, is I'll go with 52 total cards, where with the clubs I'm representing 13, as well as I'm representing the spades of 13, I get 26 out of 52. I don't require you to reduce the fraction, but it actually does become 2 out of the 4 suits that are black, and half of the cards are black. But this is fine, 26 out of 52 will show you that half of the cards are actually black. A queen. 52 cards. They always start with 52 when we're dealing with a full deck here. And we go for the queens, and the only place to find queens was in this place under the orange queen. We got 1, 2, 3, 4 queens. In club, spades, hearts, and diamonds, we have found a total of 4 queens. Does that reduce by dividing by 4 and dividing by 4? It does to 1 out of 13, because there are 13 different ranks, and one of them is a queen. If you just look at, let's say, the spades right now, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spades. Only one of those was a queen, so 1 out of 13 with the spades relates to the 1 out of 13, or 4 out of 52 in the full deck. A red 8. 52. There are only a few 8s in the whole thing, and I want the ones that are red. So I'm going to look at my 4 8s. That's as many as I might have out of the 52 cards that are 8s of any kind. Clubs are black, spades are black. Hearts are red, that's 1. Diamonds are red, that's 2. Of those 4 hearts, only half, or 2 of those 4 hearts, 2 of those 4 8s are red. And that's fine, 2 of the 52 cards are red 8s. Okay, you got a heart that's a red 8, you got a diamond that's a red 8. And the other 50 are not, right? If I want to take a quick look back at odds, instead of probability 2 out of 52, the odds in favor of it being would be 2 versus 50 that don't work. Or if we wanted the odds against it being a red 8, it would be 50 to 2 or 25 to 1. That's just a reminder about odds. A red card or a 3. So we're going to look here, we've got 52 cards that we're starting with. How many are red? Red. 13 hearts, 13 diamonds, 26 cards are red. Plus, how many 3s are there? 4 3s. They're disjoint, we can add them and be done with 30 over 52. They're not disjoint. Is there any card, or maybe more than one card, that's red and a 3? When we look at the 3s, there's a red heart, there's a red diamond. So there are 2 cards that are not allowed to stay, because they got double counted. If you have 26 cards that are red, 2 of those red cards sit among your 3s. So if they're sitting with the reds, when you go back through the deck, you're only going to find 2 black 3s to complete your 28 cards. If you were to take out the 4 3s at the beginning, then when you went back through the hearts, you wouldn't find 13, you'd find 12 more. Went back through the diamonds, you'd find 12 more. 12 and 12 plus the 2 gets you 26. 12 and 12 plus the 4 will get you to the 28 that we have. But it doesn't matter which way you go. If you let them both get counted fully, 26 of 52 and 4 of 52, but then you know 2 of them, for whichever way you want to judge them, got counted twice, you subtract the 2. 26 plus 4 is 30, but take off the 2, you got 28 of the 52. As I said, 26 red cards and 2 more for 28 that are black and being 3s, or 4 3s that are done. You go back and you're only going to get 24 cards that are red, because some are already missing, but you're going to come out either way. 28 out of 52. Does it reduce to 7 out of 13? Sure. Does that help? No, because it's not a good reduction to demonstrate, oh look, half the cards. No, it just happens to be a reducible fraction. An 9 and a heart at the same time. So we got 52 cards. If you look at the 9s, only one of them is a heart. So of the 4, we're going to get one to be a heart. The 9 of hearts, same question. I don't know if you recognize it, but that's why I put it up here. The 9 of hearts is got to be it's got to be a 9, so it's one of 4 cards. It's got to also be a heart at the same time. Only one of those 52 cards does it. These are the same answer that you're talking about, the same card. The card that's the 9 of hearts is the only card that's a 9 at the same time as being a heart. 5 or a jack. Let's take care of 5s. There are 4 5s. Those 4 5s are straight below the orange 5. Jacks. There are 4 jacks straight below the orange J. Are we done? They are disjoint sets, so we could say that we're done. Or we can even go back and say, let me subtract all the ones that are in both, which is 0. So if you want to do minus 0 over 52, that's fine. But we wind up with 8 out of 52. That does reduce with 4s to 2 out of 13. There are 13 ranks of cards. 2 of them are a 5 and a jack. The other 11 are not that. So that's why we get 2 out of 13 would do the job. 11 out of 13 wouldn't, or 8 out of 52 do the job, and the others don't. A diamond, a club, or a spade. So we got 52, we got 13 diamonds, we got 13 clubs, and we got 13 spades. Those are in rows. Clubs, spades, diamonds. Top, second, and last. Rows. 13 across each. This did not touch the hearts. It's got 39 total out of 52. You can't be a diamond and also one of the others, club or spade. You can't be a club and be a diamond or a spade. You can't be a spade, be a diamond or a club. Those are mutually exclusive. They don't overlap as sets. And this reduces to 3 out of 4 when you divide by 13. But 39 of the 52 cards do that. So that gave us the opportunity to look at the possibilities of dependence that we had here, and some, this idea of having sets that overlap. If there's an overlap, you have to erase it. You have to make sure you don't double count it. So we'll go on to another question here in homework 5. I'm going to have to erase the board and set that up for us. Now we're looking at a roll of 2 dice. The question 2 here in our homework 5 summary. When we roll 2 dice, we find the probability of, we've got here established our sample space of 36 possibilities, and we're going to go through and find out what we can get as far as the total of each of these. So we have 36 ways the dice can turn out. Where's the total of 5? We go down here and we see 1 and 4, and then 2 and 3, and then 3 followed, 3 red and 2 blue, and then 4 red and 1. Turns out we have 4 of them, and they do follow this pattern. It's a diagonal line that doesn't go any further because it can't get a die of 0, and doesn't go any further here because you can't get 5 total if one of your dice goes above 4. So we've gotten 1 with a 2 with a 3, 3 with a 2, and 4 with a 1. We've gotten here 4 out of 36. That turns out to be 1 out of 9. But 4 out of the 36 will be adding up to 5. Now, an even number out of 36, let's see. If we're in this column, we have a 1 which is odd, and we'll get an even number if we add the second number being odd. So we got 1, 3, and 5. We got 3 there. Here we got a 2 for our red number if the blue one's even. Like that 2, that 4, or 6 gives us 3. Now we got a 3. If we want to get an even number, we need another odd number to make it such as the 1, 3, or 4. Oh, sorry, the 1, 3, or the 5 to help us reach 8. 4 needs an even number, like 4 and 2, 4 and 4, 4 and 6. Every time we go through a column, we seem to be landing on 3 of them. 5 is odd, so 5 and 1, 5 and 3, 5 and 5 make even numbers. 6 needs an even number like itself. 6 and 2, 6 and 4, 6 and 6. So what do we wind up with? We wind up with 3 plus 3 plus 3 plus 3 plus 3 plus 3. That's the slow way to do it. We got 3 happening 6 times. 18 out of 36. That's 1 over 2. When you divide both top and bottom by 18, you see that half the time it becomes, and even number like that, because no matter what the first die lands on, an even or an odd number, there's an equal chance it will do what it has to create an even number by matching the even or oddness of the other one. So that's why half the time. So the first die doesn't say, oh no, I can't make it happen when we're doing even or odd. It's the second one that has to deliver the goods, and it'll do it half the time. A 1 on 1 or both dice. Okay, we've got 6 of these that have a red 1. And then something else, 1, 2, 3, 4, 5, or 6. We've got 6 of these that have a blue 1, where the red is 1, 2, 3, 4, 5, 6. So let's set that up. We've got 6 that have the red 1, first column. 6 that have the blue 1, first row. Anything to knock out. If you say that the 1 and 1 with a red 1 and a blue 1 goes with the red ones, okay, you're going to have 6 here, you're only going to have 1, 2, 3, 4, 5 there for 11. Or if you say, no, this goes on the top where all the blue 1s are, so it's got these 6, and the other ones you got 1, 2, 3, 4, 5, you got 11. What we have is if you put all 6 here and all 6 here and recognize that the one that's a pair of 1s got counted twice, you subtract 1 off, so you don't double count it, and that's how you get to the 11 over 36. Here's the red ones, here's the blue ones, here's the one that did both, the one that was a red and blue, 1 of each. A sum greater than 8. We should find where the first occurrence of a sum of 8 is, and you can't make an 8 with a 1. You can make an 8 with 2 and 6. That's not greater than 8. The first time we're greater than 8 is where we get this 3 and 6. Okay, 4 can go, so that's 1. 4 and 5, and 4 and 6, so that's a total of 3. Red 5, we can go with 5 and 4. Right, 5 and drop my 10 if I go 5 and 5, but now we've got the 5th and the 6th at the 11. And finally up here, greater than 8, we got 1, 2, 3, 4. So we got 1 occurrence of a 9, 2 occurrences with a 9 and 10, 3 occurrences with 9, 10, 11, and 4 occurrences with 9, 10, 11, and 12. 1, 2, 3, and 4. The first two didn't give us anything over 8 in those first columns. Then we got 1, 2, 3, 4. There's a pattern to this again. 10 of 36, because if we see where the 8s are, here, okay, 8 and 8, here's the 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 8, and we take the triangle that's blown. The first time it shows up with 1, then 2, then 3, then 4, then we're done looking through our sample space. 10 out of 36. Can you divide that thing by 2? Sure, you get 5 out of 18, but not for any really discernible value. One die is a 3 and the other is a 4, not or, and the other is a 4. Okay, so if one's a 3 and one's a 4, we go with the red 3 and find a 4 there. That's one of them. Go with the red 4, go with the green, with a blue 3 and find that one. That's it, those two. Or would be different. Or would be, one die is a 3, let me get all my 3s in here, right? I would get all the 3s that go this way, and 3s that go that way, right? See if there's any overlap. That'll take care of the 3s. Then I gotta go do my 4s. And you're gonna look for those as well. So that would be interesting to do that, but that's not what this one is asking for us to do. We'll wrap that up after we do this one. An even sum, or at least one die is a 5. An even sum. Well, for an even sum, we know that there were 18 out of 36 that were even. We did that up here. And the total of, and at least one die is a 5. So we go for the 5s. What we need to wind up with, besides those 18, because when there's at least one die as being a 5, okay, we're going to have, if we look across here, we're going to get 6 of them. And down here, we're going to get 6 of them. That's 12, but the 55 got counted twice. So we don't have 12, we have 11 ways that we use at least one 5. So we go here, we got 11 out of 36. But now if there's anything that's even and has a 5 in it, we can't count that. So if it's even and has a 5 in it, we can't count it. So we're looking where the 5s are. There's one that we can't count. 2 and 5 is okay. 3 and 5, that's the second one we can't count. 4 and 5 is okay. 5 and 5 is the third one, we can't count 3 of them. So it turns out that we gotta take 3 out of those 36. What's going on here? 18 out of 36 were even. 11 out of 36 had a 5 in it. Now we look at everything that has a 5 in it, and I don't know, maybe that wasn't even enough to take off those, right? I'm gonna take off more 5s. We got this 1 5, 3 5, and 5 5. That's 3 of them. Now we gotta go here, 5 1, 5 3, and 5 5 that we already did. So we actually have to take off 5 of them. That's pretty tricky. So we got here 29 minus 5, we got 24. Let's go column by column and get our totals. Maybe that's an easier way, or at least a way to confirm. I'm going to take something if it's even or has a 5 in it. Could be both, right? Even, even, even. Nothing extra with a 5 in it because the 1 5 is already counted. Okay, we go to the next one. Even, even, even. 3 evens and a fourth one with a 5. Even, even, even. So that's 3 of them. No new ones with a 5. The 4s. Even, even, even. That's 3, and that makes that. Okay. And now this one. Even, even, even. We have 1, 2, 3 that are even. And another one that's odd. And odd. What happens here is we count them through 1, 2, 3 are even, and then the ones that aren't even we got to go back and get. That's 4, that's 5, that's 6. In fact, every one of those has a 5 in it or is even. In fact, if we only look at the things that have 5 in, all 6 of them have 5s in them. So that would be enough right there. It doesn't matter about what's even. I'll go to the last one. Even. Even and even, that's 3 and 1 more for 4. Let's see where that takes us. 7, 14, 20, and 4, 24 out of 36. So that will confirm what we've been looking for as well. It sort of reinforces the rule about making sure you subtract anything that's about to be double counted. That should be enough to help get through homework 5.